In this lesson, we're going to have a look at what makes a good reflecting surface and why. So here we've got two reflecting objects. We've got a mirror here, and we've got a piece of white paper. Now, a mirror is clearly a very good reflecting object. Pretty much nearly 100% of the light that's incident on the mirror is reflected back again. But white paper is also a very good reflector. Not as good as the mirror, but it still reflects up to 90% of the light that's incident on it. So you might ask yourself the question, in that case, why can I see myself in the mirror, but I'm not able to see myself if I hold up a piece of white paper? What is the reason for that? Well, first of all, we've got to have a look and see how mirrors are made. Now, all mirrors are made from a plate of glass. And the reason why glass is used is because it is, first of all, a very hard material. That means it's not easily scratched. You wouldn't make a mirror, for example, out of perspex because it can get scratched easily. Secondly, it's a very, very smooth material, an exceptionally smooth material. Having a smooth surface, as we'll see in a minute, is very important if we want to form an image. But the problem with glass is that it isn't actually a particularly good reflector. So if a ray of light is incident on the glass surface, then only about 4% of the light is reflected back. And that's not good enough if we want to make a mirror. The rest of the light will just get transmitted straight through the glass. So what we're going to do is we're going to coat the glass with a highly reflective material. We're going to coat it with a layer of silver. Now, silver, as you know, is a metal, and it has a reflectivity of nearly 100%. So what we're doing here is we're combining the exceptionally smooth properties of glass with the highly reflective properties of silver to make our mirror. And that guarantees that nearly all of the light incident on the mirror is reflected back, and it also retains the information about the image. What makes silver a highly reflective material? Well, silver, like most metals, contains things called free electrons. So when the metal lattice forms, the metal bonds form, valency electrons are released and become free to move through the metal lattice. Now, you can find out more about this if you look to the chemistry section on metallic bonds, and you'll find that in the unit on chemical bonds. But these free electrons help to reflect the light. So you won't be surprised to find that silver is not only an exceptionally good reflector of light, but due to these free electrons, it is also one of the best conductors of electricity and also of heat. So these free electrons make it A, a good reflector of light, B, a good conductor of electricity, C, a good conductor of heat. So let's go to the paper now. You might say, well, paper's pretty smooth. If I rub my hand over the surface of some A4 paper, it doesn't feel rough at all. But we've got to examine the paper with a really high-powered microscope objective. And if we do so, we find that the surface of the paper doesn't look like this at all. It's actually quite disordered and fibrous and chaotic. All right? It may look something like this. So what happens is, as light from your image hits the paper, yes, it is reflected back. 90% of that light is reflected back. However, because of this fibrous, chaotic nature of the surface, what happens is that the light gets scattered. So it's sent back chaotically in a whole range of different directions, like this. So we say that the light that's coming in and reflected off the mirror is scattered. This effect is called scattering. exactly the same way as particles of dust scatter light from the sun. Well, the paper scatters light from the object. So the information that's contained about the image is all messed up and lost as it's reflected from the paper. That doesn't happen, however, with the mirror. Not only is nearly 100% of the light that hits the back surface of the mirror reflected, but the quality of the ray is also maintained. There's no scattering occurring because the surface of the mirror is so very, very smooth. So the information contained in the ray from the object is retained in the ray that's reflected. So we have the information is retained here, whereas here we have the information is lost.